Yeah, we just learned that quantum technologies really are, and they promise a wide range of applications. That's in academia, but also cutting-edge industrial applications. And so what we want to do now, prior to our lunch break, is to dive into one sector that might also face ethical considerations, a topic we haven't really covered so far, which is defense and security. We'll be talking about cyber warfare, about protection and potential guidelines. And guiding through the discussion will be Kathy Nickelsen. She's a consultant on business development and quantum technologies at SVA. So, Kathy, the stage is yours. Have fun. And this is our last panel prior to our lunch break.
Thank you very much for the introduction. Hi, everyone, and welcome to our panel, Quantum Technologies in Defense and Security. It's a pleasure for me to guide you through this talk and be part of this year's Quantum Summit. Before we start and jump directly into our discussion, I would like to introduce our speakers shortly. One part of our panel is Dr. Thierry, Head of Airbus Blue Sky, Deputy Head of Central Research and Technology at Airbus. He holds a PhD degree in physics from the University of California and a master's degree in aerospace engineering from the University of Illinois. He conducted his doctoral research on cavity optomechanics in the quantum regime with ultra-cold atoms. The next one is Professor Dr. Gabi Dreo Rodosek. Since 2017, she's Executive Director at Research Institute Code and also coordinator of the EU project CONCORDIA at the University of the German Federal Armed Forces. In 2019, she was named one of the 50 most influential women in Europe in cybersecurity. Great to have you here, Gabi. And last but not least, Dr. Mattingley-Scott, IBM Quantum Ambassador Leader for EMEA and AP, and he is also Deputy Chairman at the Bitkom High Performance Computing and Quantum Computing Board, and he is also advisory committee, part of the advisory committee on emerging and disruptive technology. Welcome, everybody. So let's start directly and jump into our discussion. As we all know, quantum technologies may have the potential to help, but also interfere the area of defense and security. What do you think? In which areas will quantum technologies have an impact on defense and security, and which one could it be?
I'll take it first. Thank you, Kathy. I think that quantum technologies in the plural sense of the term, including both communication, computing, and even sensing, will have a big impact in this space. Computing is, I think, known for its potential threat to some extent on communication and cybersecurity as we know it today, working from some of the classical premises that we have. That said, its opportunities are far greater than that, expanding into a broader sense of defense area, bringing about new opportunities in terms of how we design and how we consider some of our more advanced simulations. For communication, it's there as an answer, a protection against the potential future threats of quantum computers. In this sense, there's already much work happening, especially here in Europe. The EuroQCI endeavor kicked off by the European Commission, supported or further taken over by additional European entities. I think here, for instance, of ESA when it comes to the space segment is a testament to that. And then finally, for sensing, there are already such tools depending on your definition, your strict or loose definition of quantum. There are already systems that benefit from these technologies for timekeeping, for instance. But as we look ahead, there will be an even broader set of those. Work is underway now for navigation purposes, giving more autonomy to systems when they navigate by leveraging some of the quantum features and optical features that we find in objects. So I think to your question, in many ways, we believe that the quantum sector will have a big impact on the future.
If I may add, I would say if we compare today classical computers, there we can see they are more like candles. The quantum computers can be compared to light bulbs. And you see that actually we are still in the kindergarten area of quantum computing, quantum technologies. And actually we see that there are some problems that we can solve better with quantum computers, and how quantum technologies, like Thierry said, computing, communication, sensing, will influence our digital post-quantum digital society, which does not imply only defense and security, but also other areas. We don't know yet. So we have speculations what problems we can better solve, especially optimization problems and so. And certainly quantum computers will solve part of the problems that are unsolvable today. They are threats to our asymmetric cryptography, because they can solve problems like factorization of numbers, very good, which classical computers do not have. But actually today we have the three parts. We have the classical computers, we have high performance computing, and we have quantum computers. And each of these parts will be applicable for specific parts of the problems. And what and how this will be, probably in 5 years, 10 years, we will have an answer of this. But we have to start now, certainly. And especially post-quantum crypto is something that we need to tackle immediately, or to start for a quantum safe world afterwards.
So I think I'm due to make a comment. I think there are different levels. There is a perceptual level of what quantum technologies can offer today and might be able to offer in the future, particularly if we distinguish between quantum metrology, quantum communications, and quantum computing. So we have a perception of what might be possible. There is then a second level where, particularly in quantum computing, a lot of what we are expecting to happen is still very difficult to put an actual date on it, to say this will happen by this date. That's starting to become a little bit clearer. The fog is beginning to clear a little bit, but there's still a lot of uncertainty. And in the face of uncertainty, of course, especially when you're talking about defense, you need to be conservative. The third level, which I think is very appropriate here, is and I see this from the NATO point of view, the proliferation of very revolutionary technologies, and we've seen this accelerate in the last decades, has led to a proliferation, first of all, of new areas and fields of conflicts. The classical battlefield is probably it's still relevant, but or may still be relevant, but the real battles are being fought in cyberspace. There is I think, a need for a shift in how we perceive defense, how we perceive threats. And I think the key thing here is how can we frame quantum technologies in the context of stability, of a stabilizing influence. Europe is in a sense, and as a convinced European, I can say this, in a sense, it's an ideal and a platform for stability. That was perhaps the roots of its original creation. NATO certainly considers itself to be moving towards a stabilizing role. And I think that the question about quantum technologies becomes a question of what is the potential stabilizing influence, the potential stabilizing role that they can provide. Then questions about cyber defense, cyber attack, using quantum computers to perhaps solve problems which are interesting in a defense context, becomes a more rational or reasonable discussion to take.
Yeah, so that brings me to the next question. So what do you think are the difference, or what might quantum technologies make differences in cyber warfare, especially when we think of quantum computing in particular? Can we use it to protect ourselves, or may find out who the attackers are, or what can we do with it?
Offering again sort of a first perspective, I think here it's a matter of comprehending what the technology can and cannot do. I think Mark said it right. There's a perspective aspect in terms of appreciating that future, but at the same time difficult to put dates on it, and also difficult to assess in which way exactly these new tools, these new systems will come in and have a role. So as a first early point, it's an assessment. It's a translating what quantum computers can do today, which remains limited by virtue of their size, their imperfections, but still being able to comprehend what they can mean and in what way they might have an influence. And then from this first understanding to then try and get ahead of the curve, both in terms of how you think about the designing of your defense systems, be it an aircraft, a ground system, or otherwise, and as well to be able to anticipate different threats that might come from that very same tool, that very same technology. So at least in a short term, it's assessing what they can be good for, and then in a second step, anticipating how the future might look like, preparing yourselves to redesign or redeploy your systems, and what vectors of
Maybe I jump in and continue what Thierry pointed to say. The current situation we have in cyber defense is that we have a clear asymmetry between an attacker and defender. So the attacker can just use one vulnerabilities, and the defender has to defend all vulnerabilities, not even know what in the system there are. So it's a clear threat. The question is how we can flip this asymmetry in terms of making the attack surface more dynamic, more resilient, so that the attacker would have more energy necessary to give to the attack surface, and the defender would have more possibilities to defend. So the question is what quantum technologies can do here. And maybe building, as we said, maybe from the AI perspective, as we see AI now, deep learning, responsible AI, we have always two sides of a medal, using AI for dedicated attacks, using AI for defense. So there are always two parts. If we go a little bit further, let's think of a quantum internet. Let's think of quantum communications, connecting quantum computers. And quantum computers, they are on the desk, not need cooling about zero Kelvin, but really something as today's computers we have. And think about quantum app and suit the quantum communication to the physics and to the characteristics there. Maybe we can overcome this, because if you read something on quantum QKD or a key distribution, it's something really, really secure. Not what we are having here, crackable code, but something that through the physics can support this more or less 100% security. So if we see a little bit further, quantum technologies, but not knowing yet, we don't know what we have yet. We have a genie in the bottle, not knowing what's coming out. But having the illusion to say, or the vision to say that we can build something like a quantum internet, this would be really something not just good for the defense sector and the security sector, but actually for the whole society, so that we can really provide something, a secure internet infrastructure, and not something what we have now, where we have increasing number of attacks, quality, quantity. And the question is how we can really make the IT trustworthy, that all the society will trust the IT, and we are in a digital society. So I think quantum computing and all the quantum technologies have a great potential. We just have to, in the favor of the defense. So we have to see it, how we can use it.
I'd like to add to that. So I think there is a fundamental perspective on defense. Defense automatically means or implies, whether it's justified or not is a different question, but there's an implication of a reactive, unless you're an aggressor, of course, in which case that's not the case. But typically, defense means you are reacting to an actual perceived threat, or you are preparing for the eventuality of a actual or perceived threat. Which means technologically you need to be as advanced or at least parity with the aggressor, whoever that is. And in the past, that has been the way that that conflicts occur, conflicts happen. I think we're seeing this. We've seen this with the internet, with to an extent with cyber warfare, and I think there are some aspects of quantum technologies because they are. This is something fundamentally new, something we've never ever seen before. First time in human history that we're able to harness what's hidden behind an atom. I think this will, in a way, act as a kind of searchlight. It will make a lot of things and a lot of approaches we currently have will show us where their strengths and weaknesses. I think and I think it's important in that context to consider that socio-technical dimension of quantum computing. How does it fit both from a societal point of view, technology point of view, and from the society point of view? Again, coming back to what I said before, what are the stabilizing influences? What are the destabilizing influences? I like to get away from aggressors and defenders, attack and defense, but stabilizing and destabilizing, because in the long term, that's what's actually happening. Another key factor, where I think quantum computing will bring the situation we have at the moment in the world closer, will expose the reality, is the battle for resources. Most conflicts, in fact, all conflicts are about resources in one way or another. And getting a handle on that, analyzing data, being able to capture and use information and data about resources, resource deployment. And I'm talking about everything from I don't know, iron ore in the Australian mountains to wheat fields in Nebraska, or the capability to ship containers. They're all resources. Being proactive about how and where resources are used and the implications of that, and looking at strengths and weaknesses. We all remember the recent attack on the I forget the name of it, the logistics management network recently. That's the kind of scenario where we have to be increasingly vigilant. The third aspect, I think, where quantum, and particularly quantum communications and metrology, is going to really make a big change is in space. We're just seeing the beginnings of this. So we know that China is experimenting, or has experimented with entangled communication over free space between satellites and the Earth. It's kind of a toy application, but the implications are quite significant. I think we're going to see that increasing a lot. The fourth area is how will quantum technologies impact and influence overall organizations. When we look at quantum computing, for example, IBM, we've published our quantum computing hardware timeline, which goes up to 2023, which when we published it last year, September last year, I thought, oh, that's a long way away. And I've since realized and remembered it's actually only 2 years away. And we've said we're going to get to over 1,000 qubits. Some other manufacturers have made similar or more bold claims, less bold claims. I think the consensus is there's going to be, in the short-term future, there's going to be lots of qubits. The question, of course, is what can you do with them? But we'll see. There is a sense now of where quantum computing is going and what kind of speed it's moving at, then the question becomes, how is that going to change business models? How is it going to change organizational structures? We know from talking to our customers at IBM that the impact of quantum computing on entire business ecosystems will be massive. That will also have an impact in the defense area. Things that are unthinkable today may well become trivial at some point in the relatively near future. We need to be aware of that.
Maybe to add what Mark said in terms of IBM. Well, Khalil Rouhana, he's from the Commission, the Deputy Director of DG Connect, said Europe's future is quantum Europe, which means that Europe needs to team up in building quantum computers. If you see, it's a little bit weird, but the research that we need, Europe is financing research for the last 10 years in quantum theory and all quantum theoretics part. And the problem is, I like IBM, but I would like, sorry to say this, I would like a European quantum computer much better. And Europe is teaming up now for building quantum computers alone, because the all theoretical foundations, and so they are here and also in Germany teaming up. French has a big programs, Europe has a big program, because quantum technologies are something, well, as I said, the future, but on the other side, also a little bit sovereignty in terms of having the hardware, the software, the ecosystem, which Mark correctly said, it will be massive. What we will expect through these new technologies, it has to be some part also in terms of, or be a pillar of European digital sovereignty, what also Commissioner Breton said about secure connectivity, secure data, and so on. So I think it's a good point. It's not a race, but it's a collaborative work on building a secure world system and trustworthy IT. And actually, we see how important this is, that we have strong players in the field that work together, but that can also cooperatively develop new stuff. And this is far behind or beside defense. Defense is a good sector, but it's the whole society.
But Gabi, just let me interrupt you for a little one. It just brings me to the question: if do you think, Gabi, our quantum technology, is Europe in security and defense and quantum technologies lagging behind or on par with other leading regions or nations in this field? What do you think? Well, who's ahead, maybe?
Well, I would not say it ahead. We have to speed up because if you see what money is invested in either US or China or Israel or wherever, in quantum technologies, it's necessary to speed up. And Europe with the Europe flagship program. So there are some really good programs addressing the main issue in Europe. Europe is very fragmented, and fragmentation is never good. So combining, interconnecting, building ecosystems will help, and also investment, of course, to see that to team up Europe and to get in the line. So we are stepping a little bit, or we are behind, but it's necessary to be a little bit more faster. And also from the market perspective, if you see how what revenues are expected for 2030 in terms of 3 to 9 billions. So it's necessary, not just from defense perspective, but also from the business perspective, to see that Europe is a strong, really strong player in this field.
So it might be a better option to have a joint European approach here right now from the start?
Absolutely. It is. It is also in terms building. So the Commission has the programs funded, and we see a strong synergy between, for example, civil research, defense, and space. So because we see that actually we need to be smarter in terms not to work isolated, but really coordinated. And Europe is doing, the Commission is approaching this in this area really to see what are the synergies and how to support it. And let's be clear, only Europe in its own can be strong. We cannot see national parts because we are too small, but Europe in the whole, 27 member states, are strong together. They are sometimes differ and discuss a little bit more, but together they are really could be a strong or are a strong unit.
Do you think that we need some guidelines for this so that every country in Europe, can have those guidelines to have that straight way forward?
There are national strategies, national approaches like Germany 2 billion, France 1.8 billion, but they are also co-funded. This co-funding in terms of EU money, national funding, to really make this collaboration happen. And these are currently really approaches or strategies, what comes from the EU perspective, that are really strengthening this. And this is good because, as I said, only a coordinated approach can work further and to bring Europe a little bit in front or on the eye level of the other initiatives. And this is important.
I'd like to make a comment there, which is, and I said this yesterday in my talk, that I believe Europe has the necessary critical mass to lead in quantum technologies, both in the development. I mean, in the research, I agree with you, Gabi. It's Europe is the second to none. Germany is also leading the world in research in quantum technologies, and the challenge is definitely the industrialization. In terms of industrializing quantum, what do you need to do that? I have a dream of someday. If you take my MacBook Pro, open it up, and look at all the chips inside it, you'll see Korean, Taiwanese names on the chips, and the circuit board has been assembled in Shenzhen. With a quantum computer or quantum technologies, the degree of skill and engineering innovation needed means that's not going to happen, or there's a chance that won't happen. There's a good chance that when you open up a quantum computer or a entangled photonic source and look inside it, the chips have got German names on them, or French names, or Swedish names. There's a good chance that the first users, the first movers, are going to be European companies who actually use quantum computing, quantum technologies to generate value. That's the potential, that's the chance. That can only happen, first of all, with necessary investment. And secondly, you mentioned also the word, and I talked about this yesterday, key will be building ecosystems. And in Europe, there are indeed a number of regional ecosystems, there are national ecosystems, there are supranational ecosystems. The thing about ecosystems is, and in the sense of how does that tie in with a military perspective, is you need to link ecosystems in a stabilizing way. That's something IBM is doing with our IBM Quantum Network. We see it as key, not just for the generation of IP and for people to be able to work on use cases and quantum algorithms in a safe space, in a quantum safe space, but also to tie together common interests. And I see a great deal of potential in linking such ecosystems, both at the hierarchical geographic level within Europe, and also between Europe and their partners in the context of the military space. That raises a lot of interesting questions about what you do about China, and what is the potential influence of China, what's the actual influence of China in Europe. And the answer to some of those questions may not actually be very good, or not what we're looking for, but we at least need transparency and we need to work together.
On that very point that Mark just brought up, that the need to work together, I think several industry players have remarked that, following as well what Gabi was saying, the need to have a united, a very complementary effort across Europe. And to this end, several companies have come together and created a quantum industry group across Europe, already with over 100 different members, designed to do exactly what was shared, which is to have a coordinated effort to avoid segmentation, to avoid duplication, to try and find synergies where possible, and to ultimately leverage the very wide set of talents and capabilities, but at the same time, the very widely distributed set of skills and capabilities, so as to augment it. Airbus has been a part of it. We ourselves, in our own history, are a European conglomerate. We've come from different parts of Europe. We strongly believe in the need to push here for a united European effort on this technology. It will be transformative, but to be able to reach the full impact and to ensure that European players can have long-term access to the very best of capabilities, it does require this very broad, distributed, and unified approach. And I think quick, in particular from the industry side, complemented by funding programs from different countries, even at level, is a good formula forward for Europe to really capitalize and succeed.
Okay, so I see some questions. No, I see one question in the chat right now, which I want to ask you. Is the use of quantum annealer for troop logistics thinkable, or is it already being considered?
Quantum annealer, this is, for example, the D-Wave quantum computer, but there are several architectural parts currently discussing how the architecture of a universal quantum computer could be. The annealer are very good in optimization problems. But the question is if this is then really universal enough also for other parts of the problem. And I think we are still, as I said, in the kindergarten part. We are playing with hardware. We are saying what could be better, but we still don't have this universal quantum computer. And maybe 5-10 years, let's see it as a crystal ball, we will have something that is really universal use.
So if I understand correctly, and incidentally, we do kind of technically have a provider of annealers here in Europe. I say kind of technically. One of my co-board members is from Fujitsu, formerly Siemens Fujitsu. They also have an annealer platform. And as Gabi mentioned, annealers are very good at solving binary optimization problems, or let's say are postulated to be very good at solving those problems. I think the proof is also still not formally verified. Particularly in logistics, yes, there are a number of real-world problems which you can map onto, or which are inherently of that kind. Is that realistic for real problems today and the dimensions and sizes we would need them to be in order to outperform classical computers? If I understand correctly, we're not there yet. Whether annealers are going to be a viable bridge to noisy intermediate scale quantum computers or error-corrected quantum computers, or whether those universal quantum computers, the development, the roadmaps, the hardware development obviates that in the sense that we get universal quantum computers, usable ones, in a sufficiently short timescale. That's all, I think, completely open. So it's very, very difficult to speculate on, which technology is going to be useful in which scenario. And if you're looking for what should one do, I think you would be well paid to cover not just one base, but also look at NISQ machines for the person asking.
Yeah, and I would take even one step, sort of zooming out from that question. It discerns quantum annealers from the digital quantum computers, the latter of which is aimed at ultimately yielding universal quantum computing. But even beyond that, the quantum computing space in general adds itself to a very wide array of other computing platforms, high-performing computing platforms. And being able to address and assess this wide spectrum and understand how quantum computers, irrespective of their flavors, can be added and complement the tools that we already have. So really to best leverage the variety of quantum computing, of computing tools that exists, is I think an important aspect. Certainly for us at Airbus, this is something that we've taken on very seriously. We understand that there's this growingly heterogeneous set of tools out there, and that in order to best prepare ourselves and best update our ways of working, well, we really need to have a good understanding of this broad swath, and as well how those quantum computers, irrespective of their first usage areas, the way they will be brought on is most likely as a co-processor sitting side by side to another computing platform. So being able to draw those ties requires a slightly broader perspective.
Okay. I want to cover some comments from the chat, and he says that the multi-layer approach, the bridging the cyber-physical gap and including physical-based infrastructure into a security matrix, the layer is still the easiest to attack, to corrupt, and impacts thereof are manifold and fiery-chain. And security is gone when an attacker has access to the data stream, regardless its structure and type of encryption. What do you say to that? Know what?
I'm not sure if I can start, but I'm not sure if I understand correctly the question.
Okay.
It's always so. It's always a race between between attack and defense, and the good, let's say, from quantum communication, quantum key distribution is so that in terms, if you are reading once or accessing the data, what is transmitted over them, it changes states. It's naturally quantum physics, and so it cannot be done without notice. So from this aspect, we could say that this is really, really secure, more 100% secure. Currently, we are living in a non-secure world, but quantum world could be a potential to give it to the potential to make it more secure. And actually, what we are seeing, we're talking today about quantum computing and quantum technologies, but cybersecurity in the future, cyber defense will depend on AI development and on quantum computing, quantum technologies. For example, quantum machine learning, giving us possibilities where deep learning can have absolutely other good results than we have today. So it is a really fast evolving space and development. It's so let's say crazy and good, because never so far the technology has evolved in such a fast dimension and complexity, in which it's good, because it helps us to make this world more safer, more secure. But of course, on the other side, imposes also a little bit more threats, AI-based attacks, for example. And we see we don't need even this with SolarWinds. It can be even easier to manipulate, for example, the Orion network management platform. Anyway, technology, we have to embrace it and really to see the good of it. And of course, it's our job to make the world more secure. So, and it is from the industry to research to all of us, and all has their part to do.
Thank you for that last words, because we're unfortunately running out of time. So I would like to thank all of you for your contribution and the very interesting talk. Thank you very much to all panelists, and have a lot of fun in the rest of the summit, and have a nice day, and thank you for having you here.
Thank you. Bye-bye.
Bye-bye.
Bye.